A coolant is a fluid which flows through or around a device to prevent its overheating, transferring the heat produced by the device to other devices that use or dissipate it. An ideal coolant has high thermal capacity, low viscosity, is low cost, non-toxic, and chemically inert, neither causing nor promoting corrosion of the cooling system. Some applications also require the coolant to be an electrical insulator. While the term coolant is commonly used in automotive and HVAC applications, in industrial processing, heat transfer fluid is one technical term more often used, in high-temperature as well as low-temperature manufacturing applications. Another industrial sense of the word covers cutting fluids. The coolant can either keep its phase and stay liquid or gaseous, or can undergo a phase transition, with the latent heat adding to the cooling efficiency. The latter, when used to achieve low temperatures, is more commonly known as refrigerant. Gases, air is a common form of a coolant. Air cooling uses either convective airflow, or a forced circulation using fans. Hydrogen is used as a high-performance gaseous coolant. Its thermal conductivity is higher than all other gases, it has high specific heat capacity, low density and therefore low viscosity, which is an advantage for rotary machines susceptible to windage losses. Hydrogen-cooled turbine generators are currently the most common electrical generators in large power plants. Inert gases are used as coolants in gas-cooled nuclear reactors. Helium has a low tendency to absorb neutrons and become radioactive. Carbon dioxide is used in MagNOx and AGR reactors. Sulfur hexafluoride is used for cooling and insulating of some high-voltage power systems. Steam can be used where high specific heat capacity is required in gaseous form and the corrosive properties of hot water are accounted for. Liquids. The most common coolant is water. Its high heat capacity and low cost makes it a suitable heat transfer medium. It is usually used with additives, like corrosion inhibitors and antifreeze. Antifreeze, a solution of a suitable organic chemical in water, is used when the water-based coolant is to withstand temperatures below 0 degrees Celsius, or when its boiling point has to be raised. Butane is a similar coolant, with the exception that it is made from pure plant juice, and is therefore not toxic or difficult to dispose of ecologically. Very pure deionized water, due to its relatively low electrical conductivity, is used to cool some electrical equipment, often high-power transmitters and high-power vacuum tubes. Heavy water is a neutron moderator used in some nuclear reactors. It also has a secondary function as their coolant. Light water reactors, both boiling water and pressurized water reactors the most common type, use ordinary water. Polyalkylene glycol is used as high-temperature, thermally stable heat transfer fluids exhibiting strong resistance to oxidation. Modern PAGs can also be non-toxic and non-hazardous. Cutting fluid is a coolant that also serves as a lubricant for metal shaping machine tools. Oils are used for applications where water is unsuitable. With higher boiling points than water, oils can be raised to considerably higher temperatures without introducing high pressures within the container or loop system in question. Mineral oils serve as both coolants and lubricants in many mechanical gears. Castor oil is also used. Due to their high boiling points, mineral oils are used in portable electric radiator-style space heaters in residential applications, and in closed-loop systems for industrial process heating and cooling. Silicone oils and fluorocarbon oils are favored for their wide range of operating temperatures. However, their high cost limits their applications. Transformer oil is used for cooling and additional electric insulation of high-power electric transformers. Fuels are frequently used as coolants for engines. A cold fuel flows over some parts of the engine, absorbing its waste heat and being preheated before combustion. Kerosene and other jet fuels frequently serve in this role in aviation engines. Freons were frequently used for immersive cooling of, for example, electronics. Refrigerants are coolants used for reaching low temperatures by undergoing phase change between liquid and gas. Halomethanes were frequently used, most often R12 and R22, but due to environmental concerns are being phased out, often with liquefied propane or other halalkanes like R134A. Anhydrous ammonia is frequently used in large commercial systems, and sulfur dioxide was used in early mechanical refrigerators. Carbon dioxide is used as a working fluid in climate control systems for cars, residential air conditioning, commercial refrigeration, and vending machines. Heat pipes are a special application of refrigerants. Molten metals and salts equals. Liquid fusible alloys can be used as coolants in applications where high temperature stability is required, for example some fast-breeder nuclear reactors. Sodium or sodium-potassium alloy NaK are frequently used. In special cases lithium can be employed. Another liquid metal used as a coolant is lead, in for example lead-cooled fast reactors, or a lead-bismuth alloy. Some early fast neutron reactors used mercury. For certain applications the stems of automotive poppet valves may be hollow and filled with sodium to improve heat transport and transfer. For very high temperature applications, for example molten salt reactors or very high temperature reactors, molten salts can be used as coolants. One of the possible combinations is the mix of sodium fluoride and sodium tetrafluoroborate. Other choices are FLiBe and FLiNaK. Liquid gases Liquefied gases are used as coolants for cryogenic applications, including cryo-electron microscopy, overclocking of computer processors, applications using superconductors, or extremely sensitive sensors and very low noise amplifiers. Carbon dioxide is used as a coolant replacement for cutting fluids. CO2 can provide controlled cooling at the cutting interface such that the cutting tool and the workpiece are held at ambient temperatures. The use of CO2 greatly extends tool life, and on most materials allows the operation to run faster. This is considered a very environmentally friendly method, especially when compared to the use of petroleum oils as lubricants. Parts remain clean and dry, which often can eliminate secondary cleaning operations. Liquid nitrogen, which boils at about -196 degrees Celsius, is the most common and least expensive coolant in use. Liquid air is used to a lesser extent, due to its liquid oxygen content, which makes it prone to cause fire or explosions when in contact with combustible materials. Lower temperatures can be reached using liquefied neon, which boils at about -246 degrees Celsius. The lowest temperatures, used for the most powerful superconducting magnets, are reached using liquid helium. Liquid hydrogen at -250 to -265 degrees Celsius can also be used as a coolant. Liquid hydrogen is also used both as a fuel and as a coolant to cool nozzles and combustion chambers of rocket engines. Nanofluids an emerging and new class of coolants are nanofluids, which consist of a carrier liquid, such as water, dispersed with tiny nanoscale particles known as nanoparticles. Purpose-designed nanoparticles are, for example, CuO, alumina, titanium dioxide, carbon nanotubes, silica, or metals dispersed into the carrier liquid. This enhances the heat transfer capabilities of the resulting coolant compared to the carrier liquid alone. The enhancement can be theoretically as high as 350%. The experiments, however, did not prove so high thermal conductivity improvements, but found significant increase of the critical heat flux of the coolants. Some significant improvements are achievable. For example, silver nanorods of 55A plus or minus 12 nanometers diameter and 12.8 micrometer average length at 0.5 vol. % increased the thermal conductivity of water by 68%, and 0.5 vol. % of silver nanorods increased thermal conductivity of ethylene glycol-based coolant by 98%. Alumina nanoparticles at 0.1% can increase the critical heat flux of water by as much as 70%. The particles form rough porous surface on the cooled object, which encourages formation of new bubbles, and their hydrophilic nature then helps pushing them away, hindering the formation of the steam layer. Nanofluid with a concentration more than 5% acts like non-Newtonian fluids. Solids. In some applications, solid materials are used as coolants. The materials require high energy to vaporize. This energy is then carried away by the vaporized gases. This approach is common in spaceflight, for ablative atmospheric re-entry shields and for cooling of rocket engine nozzles. The same approach is also used for fire protection of structures, where ablative coating is applied. Dry ice and water ice can be also used as coolants, when in direct contact with the structure being cooled. Sublimation of water ice was used for cooling the Project Apollo spacesuit. References. External links: CO2 is a natural coolant. FAQs.